hailing from Germany, and all the way from the powerful physical sciences area. Please give it up for Dennis Noll.
Let me take you back to your childhood. It's summer. The vacation just started. Your best friend came over. You're sitting on the carpet in the living room and have a big box of Lego bricks all over the place. Just a few simple bricks and your imagination, enough to construct whole worlds. Little did your younger self know, this is actually how the world works. And I'm not talking about molecules or atoms. I'm talking about something much smaller, much more fundamental. Elementary particles. Up until now, humanity has found 17 of these elementary building blocks, and they make up everything we see on this planet. The catch? When we look above the boundaries of Earth, at the rotational speed of galaxies, or the expansion of the universe, we see that these bricks can only describe 5% of the energy content of the universe. Imagine having only access to 5% of the box. Your imagination would be severely limited, and so is our understanding of the universe. So how do we find the other 95%, Dennis? I'm glad your curious inner child asks. At the beginning of the 20th century, a smart man told us E equals mc squared. So if we put enough energy at one point in space, we can actually create new mass, and amongst it maybe new particles. That's why we built powerful particle accelerators, smashing protons with almost the speed of light. We capture the new particles with giant detectors, 50 meters long, 25 meters in diameter, and fasten your seatbelts, making 40 million pictures each second. Around 10,000 people around the world run these experiments, 50 here at Berkeley Lab. My group and I specialize in artificial intelligence to analyze the massive amount of complex pictures. Our current approach uses two AIs, Alice and Bob. First, we teach Alice what the detector pictures would look like if you only had these 17 particles. Just like ChatGPT here knew what a big box of Lego bricks looks like when I asked it to draw it for this talk. Then we let Bob autonomously compare Alice's predictions with the real-world measurement. The only difference he can find is something missing in the model. So Bob is directly looking for the missing 95%. Until now, we have shown that Alice and Bob do a great job together, and they already started looking places that nobody looked before. However, as all AI methods, Alice and Bob are very data hungry, and they need more pictures to potentially find something. That is why, as I talk to you, our collider is running and our detector is gathering more and more data. Once the data taking is finished, we'll invite all our friends, sit down on the carpet in the living room, dump the box of Lego into the ground, and start looking for particles beyond our imagination.